Hey, this is Elizabeth and we're gonna do the workshop number 1. First, we gotta create a new database on new file. We open up the folder we are working on. And we name it Piston. We click OK. We check that the tolerance is based on model, the analysis code is MSC Nastran, and the analysis type is structural. Then we click OK. After that, we need to import the model geometry. For that, we click here on File, and we click Import. We select the file .xml. This window is gonna pop up. We click OK. After that, we put smooth shaded so we have a better vision of the model. And with the middle button of the mouse, we click it and we spin it to have like this view. After that, we create a finite element mesh. In the tab of meshing, we gotta create a mesh solid type. It needs to be TED, the measure needs to be TED mesh, and the topology TED 10. We select solid 1 under input list, that's this one, and we unchecked the automatic calculation and we write 0.5. After that, we click apply and the mesh is done. Then we create the constraints. We go to load VCs. We create a displacement. The type is gonna be nodal. We name it fixed. On input data, we gotta write on translations 0 space 0 space 0. Just on translations. Then we click OK. On the application region, we're gonna select the 2 pinholes. We click the icon of surface or face right here, and we gotta choose this face, click add, and the one in the back, the add. After you chose the both, we click OK and we click apply, and there you can see it's fixed on 3 degrees of liberty. We create after that the pressure load here in the same tab. We create a pressure and the type is gonna be element uniform, and we are gonna name it piston low bar pressure. We input data and it's gonna be 1200. We click OK. The application region is gonna be the top face. We click add, OK, and we're gonna click apply, and there we can see that the pressure is being applied. After that, we are gonna create the material that is gonna be composed. On properties, we click isotropic, manual input. We're gonna name it steel. The properties are gonna be, it's gonna have an elastic modulus of 36. and a Poisson ratio of 0.3. We click OK and we click apply, and there we can see here that our material has been created. After that, we go to create in 3D properties, solid. We click this icon. This is gonna change. It's gonna say create 3D solid. The property set name is gonna be Piston. The options need to be these ones. On input properties, we're gonna choose the steel, and then we click OK. On the application region, we're gonna click the whole piece, solid number 1. We add it, OK, and then we click apply. After that, if we want to verify the load cases, we can go home, display the model 3 here. We can double click this bar. Oh. We're gonna open this one, that's load cases. It's gonna say default. We're gonna double click, and here we can see the displacement we name fix and the pressure that we name piston pressure. We click cancel and we can close this up. After that, we're gonna go to the analysis. We're gonna do an entire model analysis deck. The translations parameters, it needs to be small, card format small. You click OK. The solution type needs to be linear static. OK, and then we click apply. Then here on XDV, we're gonna select results file. We're gonna select the point XDV. We click apply. After that, we're gonna go to the icon of plot erase that's in home, hide miscellaneous, and we're gonna erase under geometry. After that, we're gonna go to results. We create a quick plot, and we're gonna select the stress tensor under select fringe result, and we're gonna select the displacement stress rational and apply. The quantity needs to be bond misses. After that, we're gonna click on the deform attributes icon. We're gonna uncheck the show on deform and the title, and we click apply. We're gonna go back to the plot erase icon, and we're gonna click erase under geometry again, and we click OK. After that, we're gonna select the fringe attributes icon, that's right here. We're gonna set display element edges. We're gonna uncheck this box, show title, and we apply. And that's it. That's the illustrated model of deformation and stress fringe plot.